For our final session of the day, titled The Future of Space Exploration, please welcome Mark Kirasich, Vice President of U.S. Operations at the Exploration Company, for a fireside chat with Martijn Rasser, Senior Advisor at SCSP.
All right, good afternoon, everyone. Final session of the day. Mark. So, topic of discussion, future of space exploration, and it's a real privilege to have you here, Mark. I mean, you're a true pioneer, architect of human spaceflight, particularly for the next generation. Want to touch on some highlights of your career, because it tees up the question I want to ask you. So, 4 decades at NASA, you managed the Orion program, served as Deputy Associate Administrator for the Artemis campaign development, then you went to Blue Origin, and you're now at the Exploration Company, where you head U.S. operations. So you have a tremendous amount of experience with 3 very different organizations. So what I'm curious to know from you is, based on what you've seen and experienced in terms of pace, risk tolerance, decision-making culture, what's the single most profound difference that you've observed over the course of your career?
Yeah. First of all, thanks, Martin. I appreciate the opportunity to participate and the invitation to be here today. And yes, you highlighted the 3 places I've worked over my career, and there are some differences between the 2. The 2 that stick out to me as I think about, well, what drives pace, what drives risk acceptance, is a couple of things. I'll start with size, and I'll start with the company I work for now, the Exploration Company. We're a young company, 4 years old, and we're still small. Now we're growing fast. Over the past year, we went from about 160 at the start of the year to we're going to peak at 400 at the end of the year. But still, the smallness of it, it's amazing how I can look at the decision chain and how easy it is to go from the bottom of the company to the top of the company and make decisions compared to some of these larger organizations I work for. And I think that enables decision velocity a lot. We also have a CEO, our founder, Elaine Hubie, who really emphasizes this, puts it in the culture of the company, pushes accountability, pushes responsibility down. So everybody, even the entry-level engineer, they know what they're responsible for. They have to deliver something, and then we encourage them to make the decisions. So size is a really enabling factor that I've observed helps us in my current company move fast. The other thing I wanted to mention, especially when I compare 40 years of the government with working at 2 privately funded organizations, Blue Origin and now the Exploration Company, in both cases, the companies brought private capital, brought essentially their own money to the table and made significant investments. For example, now on the operational spacecraft we're building, the company's investing about 40% of the cost of developing our new low Earth orbit transportation vehicle. And what that does is in the commercial environment, that allows, first of all, the government recognizes this, and there's a risk sharing. And some of the risk, more financial risk is taken on by the commercial company. And in the process, when we find you control a budget and you've taken that financial risk, there's more of an impetus to when topics of schedule, when topics to be willing to decide to go faster, to go quicker, perhaps take on technical risk. Risk is still ever present in all the discussions, because in the end we have to make money, but the fact that it's your money causes you to want to move fast. And we have a saying, develop fast, build fast, test fast, learn fast. And we're not always successful, but in all cases we learn. And sometimes, and I've learned this even from my earliest days at NASA, you learn the most from when you don't succeed as opposed to when you do.
So given those dynamics, and what does that mean then for innovation? Where do you see the most significant innovation happening? Is it in government, established commercial, new ventures like the Exploration Company?
Yeah, it's as I think about this, I'm going to answer the environment. At least in my career, my 40 years in the industry, it's a very unique time. I've never seen as many small new startups in the industry. I've never seen, and these startups are attracting a lot of capital. I just read this morning about how one young company received a fairly big investment from the Janus investment firm. So that's enabling a lot of innovation. And I would say it's across the spectrum. First of all, the fact that there's so many of us, it drives competition. And I can tell you, I'm very proud of our company. We have flown 2 spacecraft, by the way, in our 4 years. The first spacecraft we developed in 9 months. So I think we've demonstrated the pace, but just about every day I log on, I read the latest newsletter, and there's another new small space transportation company with a different shape. And I'm looking, and they're saying they can, if we develop ours in 9, they're promising 8. So I'm looking at their shape and I'm wondering, how are they doing that? So it drives a lot of competition. I think this is really healthy. In terms of where is it now? Where is the innovation coming from? Well, I look across what I'll call the mature commercial companies. SpaceX, look what they're doing with the Starship. So I think they're still really innovating. I look at us at the other end of the spectrum and what we're doing in our capsules, making them more reusable, the way we're using them to lower cost, and everybody in the middle. So I think it's across the industry, and I think it's the environment. And the government has a key role too. The government's enabling commercial, they're investing. So I really think it's a very unique time for innovation, and we're going to see a lot of growth, a lot of things in space in the years to come.
Yeah, so you're describing a public-private partnership model. That's quite different than how it was during the Apollo era. So what do you see the big strength, but also one of the major weaknesses of this public-private partnership model being?
Yeah, very, very interesting question. I spent 40 years, I'll say 40 years of my career building the traditional model, if you will, building how governments interact with companies. And I would say it was, towards the end of my career, it was very healthy to have people pushing the commercial approach. And maybe I'll talk about what I see as a couple of the key enablers, and that really drive the difference. And believe me, over my career, I saw what happened. We didn't move as fast as I wanted to move. We costed more than we wanted to. All of us did in the traditional programs, and all of us, nobody liked it, but it's where we were. But I think there's a couple enablers in the new system. The first thing I'll talk about is competition. Every one of the, if you think back, if you watch NASA and the commercial programs, commercial cargo, commercial crew, the commercial approach to the human landing systems, the initial award for spacesuits, and now the competition we have for surface rovers, every one of those had a goal and initially picked more than one prime contractor. So we awarded 2 contractors. And that caused, first of all, that created a competition among them to perform. It also provided resiliency. And we've seen it in the operations of the vehicles. When one has a problem, the one is there. So the competition, the approach to having 2 available, I think is a big factor. The second thing that you have to talk about is the contracting approach. In all of the traditional government programs that I was involved in while I was with NASA, we used cost-plus contracts. In the commercial approach, most cases are fixed price, and I don't think anybody necessarily intentionally uses cost-plus to drive costs up, but you're just not as motivated. In fixed price, you are motivated every day to meet that schedule. You're motivated to look harder, strike harder deals with the supplier. There's a real motivation that we just didn't quite have when you have a cost plus, where, okay, I went a little over in schedule, or I may not argue this price down as much as I should because it's a cost plus environment. I think that helps a lot. And the government helps too, though, because another thing that enables the companies to innovate is the government, their contribution is they back off the requirements. The requirements we had at the start of the Orion were measured in hundreds, and in the early commercial cargo, commercial crew days, you could did I say hundreds? Thousands of requirements. NASA's backed way off in these commercial, where you're down to really key performance requirements. And that helps these new companies a lot. It gives them flexibility. It gives them flexibility to innovate. And along with that is the oversight. How many government people watch the contractor work? So all these things, they kind of play together, and I think are really big enablers of this newer, more commercial approach to our industry.
Great, excellent. Let's pivot to Artemis, right? So the Artemis campaign aims for sustainable lunar presence. In your view, what's the one critical piece of infrastructure or technology, so beyond the landers, that we really need to be able to successfully deploy and make lunar exploration sustainable, right? It's more than footprints and flags, but a true permanent presence.
Right, that's what all of us want. That's what I worked really hard for my last couple of years at the agency. And you mentioned like the HLS, and I know there are pieces. We have the Gateway, which will be an orbiting platform, an orbiting human-capable platform. We're working on the surface systems, power systems, navigation systems, comm systems. But I'll go back to you said besides HLS, I strongly believe that what's going to really enable sustained presence and continued presence is we have to get the end-to-end transportation. We have to get the cost lower, and we have to make it more regular. We have to make it more reliable. When I say that, we're barely starting to fly. SLS Orion has flown once. We'll fly the first crewed mission in the spring. The landers are coming, but we've invested a lot of money, and we have to get those costs down, because that drives everything going back and forth. I can tell you, especially in the world when I'm on the opposite side now, building a transportation system, lower cost enables all of the applications. The governments that want to do more science, that want to explore. The cost per kilogram today is just too high. The commercial industries, the people that are trying to do in situ resource processing, manufacture, for example, propellants, or for example, mine helium-3, bring it back to Earth. Their biggest challenge, again, is the end-to-end transportation. So as perhaps as unsexy as it sounds, we have to do what commercial crew did for the space station and for low Earth orbit. We have to get flying, and then we have to get the cost down to enable this growth, to enable this sustainability.
Let's dive into the work that you do at the exploration company. So first, tell us about NICS, what that is, what sets it apart, and then as a follow-up, in particular in your role heading U.S. operations for the company, we had a great conversation in the green room before we came on stage about some of the specific challenges, as the U.S. representative of an international company headquartered in Europe. Well,
yeah, good.
Love to dive into that too.
Thank you. Yeah, there are a couple of parts to that. Make sure I hit them all. Let me start by saying I was drawn. I left NASA after 40 years. I went to Blue Origin. I was intended to finish my career there, but I got a very interesting phone call from Elaine Hubie, our CEO, one of the founders of the exploration company, who I had met while I was the NASA Orion program manager, and she asked me, did I want to join the exploration company and open essentially the U.S. office. And that sounded really exciting. It was really the one reason I would have left for. And when you go to, if you go to our website, our purpose, it ties back to the last question. Our purpose is to make space more accessible, more people flying, and more collaborative. We are an international company. We have 4 offices in Europe. We have an office in the Middle East. Now we have an office in the U.S. Those are really foundational principles to make space more accessible, to lower the cost, exactly what I was talking about previously. A little bit about our product line. We're 4 years old. As I mentioned, to date we've built and flown 2 spacecraft. Both were subscale spacecraft. The first, when the company was started, Helene brought $50,000 into the company. She had a little help from an angel investor, and we built a very small, less than a meter diameter, 60 centimeter spacecraft that flew on the first Ariane 6 flight a little over a year ago. And that led to us raising some additional money through a Series A funding, and we built a second larger spacecraft, 2.5 meters, called Mission Possible. This one actually had prop system controlled reentry. The first was ballistic reentry only. And that flew just this past year on a SpaceX, again, another commercial innovation, a transporter mission. And I did not fully appreciate what SpaceX has done in that market. We were one of over 60 spacecraft that SpaceX mission deployed in that flight. So that was our second mission, 2 years. And now you brought up NICS. NICS is all of that are the low cost we demonstrated, the speed which we demonstrated on those first two developments really enabled the company to be very competitive as a young company for ESA's, the European Space Agency's first foray into the commercial approach, if you will. It's called LCRS, Low Earth Orbit Commercial Return Services. In the US parlance, it's LEO cargo, up and down. So we were very competitive. We won, we were one of the 2 awardees for that contract, and our spacecraft that we're building support that will take cargo about 4 metric tons to a space station and then return a similar amount of mass back to the Earth. NICS is our spacecraft. It's a cargo spacecraft only. And we are targeting, in this past year, if you've dealt with NASA before, they have a very high bar, especially if you're going to dock to the International Space Station, a very high bar on integration standards, on safety standards. We passed our preliminary design review and we passed our safety review over this past year. So we're now halfway to our critical design review, which we'll do next fall. So that's our next Earth spacecraft. Now let's see. The last half of the question, I'm sorry, Martin, I lost the.
Well, some of the
challenges.
particular challenges, yeah. Because again, I was in a similar position prior to joining SCSP, where I had to navigate, running the U.S. arm of a European company.
Yeah, that's something, again, since I opened the subsidiary, I learned a lot about, and they don't exactly teach you when you join a big organization like NASA, but I thought, I'm going to come to that exploration, I'm going to build new spacecraft, but I found out everything from you want to get paid to have health insurance to, you have to set all that up, and that's the easy stuff. There are people that can help you with that, but when you're a company, an international company that has its roots in Europe, and you're opening up the first U.S. office, that has some special challenges. And just a couple to cite. First of all, there's these things about countries, and when they develop technology that can be used for defense, as a lot of the products we do here, other export control laws, and we are flat in the middle of it. We develop spacecraft that can re-enter, no less. So we have to pay attention both ways. We have to be really careful when the Europeans send it. We can have a European employee in Europe, in Germany, working on the same system, the same technical problems that the U.S. tech employees working on, and we just have to be really careful about information exchange. So export control is something you have to pay very close attention to if you're international business. And the other interesting thing I didn't fully appreciate, I guess I always knew about it. I did know about it. I led many procurements at NASA, but it's different when you're on the other end. At the moment, our U.S. subsidiary it's a subsidiary of a European-owned company. And if you're trying to bid on the kinds of things we want to do, we want to build spacecraft for not only the civil but also defense needs. All the governments want investment in the host country, and they want the work to be done in the country. So what we're doing right now, to be a truly international company, we're opening a sister entity, which will be right now in the head of Tech, what we call the Exploration Company US, Tech US, which is this wholly owned. We are opening another legal entity that we'll call Tech Federal. It will be over 51% owned by U.S. citizens and over 51% controlled, including the board of directors, including the officers. So that will allow us to compete here in the U.S. for government-based business. So there's a lot of things that you have to consider. There's a lot of benefits to being international. Clearly we can draw on a lot of the different investment communities. The people here. Right now, even though most of our engineering, most of our manufacturing is based in Europe, There's about 15 people out of our 400 that are engineers who live and work in the U.S. that support the development of engineers. Because when we had a competition, when we posted our job, they were the best people for the job. So being international open creates a lot of opportunities. You have to work through some things to get started.
Let's talk about Mars, right? It's been a long-standing fascination of mankind. I think inspiration for a lot of science fiction that hopefully will soon become science fact. So you oversaw the architecture for the Artemis campaign. In terms of non-engineering hurdles, what do you see as being the biggest one?
Yeah, well, first of all, Mars is a dream. It's a dream. I hope we get there during my lifetime. And yes, we worked on both getting back to the moon and the Mars architectures. And there are a lot of challenges. I would tell you, it's still a scientific challenge. The thing that I found that I still feel is most daunting is just the human health, human performance, the psychology aspects, physiological aspects of going to Mars. You know, even though there's shorter duration missions, when people go for the first time, it'll still be the longest time people have spent in space, even with the long duration missions we've had on board the space station. And so that creates several challenges. First of all, they'll be outside of the Earth protective shield. Radiation is high. It's long duration. You have to take really good care of your body, exercise, and that's where the space station has really helped us. We've learned a lot about the microgravity effects on the body, on our bone structure, on our circulation system, on our eyesight, how our eyes work. What else? Just the fact of being isolated so long. Another example of the space station, when I was actually a flight director in the earliest days of the space station, the first time we flew American astronauts, and by the way, the internet was new at the time, and the use of the video telecom was very, very new. And the favorite system of everybody on board was the fact that they could use the computer network to call whoever they wanted back here on Earth. And they literally, we used to send them fake phone bills, but they spent a good part of their weekend communicating. It was something we learned on space station. We'll have to make sure there's an equivalent for the people that go to Mars. So I think it's taking care of the human being is what I worried about the most. And I'll add that what we have in LEO today, the International Space Station, it has been hugely beneficial in terms of learning more about that and buying down the risk. The things I talked about, the things we've learned about what happens to the human body. And also a big advantage of the Gateway, I'm not sure if folks are familiar with this. The Gateway is the crewed space station, the smaller that we'll put in a lunar orbit. But one of several reasons we're putting it there is it's a very good place to do more, even closer analogs to a Mars mission, because what will happen is people will travel to the Gateway, they will spend time on board the Gateway and eventually extend a period of time, months on the Gateway, and then they'll go down to the lunar surface as if somebody would go to Mars, spend time there in a microgravity field, come back up, spend more time there, more time in pure zero G before they finally come back to Earth. So it will be much closer to a real analog of what it will be like to travel to Mars, to learn even more about what Mars is going to do to the human body.
So looking ahead 10 years, what's going to define human space exploration? Is it a permanent base on the moon, clear trajectory to Mars, self-sustaining LEO economy?
Yeah, that's a tough one, and I got to name just one. The first thing, you know, when you list all those three, the thing that pops out of me, can you believe, and part of this again is the environment we lived in. We talked about the commercialization, but can you believe we're sitting here and even talking about doing all three in the next decade, talking about commercial LEO operations, talking about returning to the moon and establishing permanent bases there, or longer crewed bases there, and talking about sending people to another planet for the first time. So I think that's a statement in and of itself. We're in a really great time for people who are interested in human space flight. I want to see all three in the next 10 years. But you know, if you ask me to name one, we have to build on what space station has built, and we have to keep. We are so close. The investment we made in low Earth orbit in different pharmaceuticals manufacturing, things that when we were selling the space station 30 years ago were just, our goals, they're very close to coming to fruition. I think it's really important that space stations get in just a couple of years, that we field these commercial LEO space station destinations, that we build the infrastructure, and then we continue here. It's the closest place, it's the place to learn, and there's a lot of opportunities, a lot of investments. By the way, that doesn't mean I don't want to get to the moon, doesn't mean I want to get to Mars, but I really place a lot on making sure we keep the ball going here in LEO.
So as we close the first day of this summit, you've worked on some of the most ambitious projects in space history. As a takeaway for everyone here, what's the single most important lesson in leadership that you've learned? Because we're talking about life and death situations oftentimes. What would that be for you?
Yeah, well, and it's something that I was an engineer by education, and it's something that, well, some people would say I'm still not very good at, but I didn't have a concept of it when I was 25 years old and I was thrust in the first leadership position, but it really is about the team. It's about teamwork. The kinds of things we do, they're so complex. It takes, even in the faster, cheaper commercial environment, it still takes a lot of people communicating, getting the job done. So it's about keeping the team together, leaders having integrity, open communications, a common mission. The thing I really loved the day that I walked into the doors at the Johnson Space Center over 4 years ago, sense of mission. The sense of mission in our industry is so strong, and that provides a good foundation to bring people together. And then the leaders, they need to make sure they're leading their teams, keeping the communications open, establishing trust, because it takes a lot of people, and that's really what enables these great things that we do.
It's a wonderful note to end on. Mark, thank you so much for being here today. Please join me in thanking Mark Kirasich.
Thanks.
Ladies and gentlemen, this concludes today's programming.